This is going to be the last video on solving trig equations, and I'm only going to look at two examples. And here we're going to have one slightly different topic to handle. And if we look at the first one, we have 2 times the sine of 2x plus the square root of 3 is equal to 0. And you'll notice right here this sine of 2x is the part that's different. All of the equations before, whatever the trig function was, if it was the sine, it was simply the sine of x. But now we're looking at this part that is the sine of 2x. So we're going to set this up and solve just like we did before. We want to isolate the sine of 2x, so we want to get this piece by itself. And to do that, we need to first move over the square root of 3. So we would have 2 sine of 2x equals negative square root of 3. And then we can divide by the 2, and we would be left with the sine of 2x is equal to negative square root of 3 divided by 2. So now when we look at this, we're going to go to the unit circle, just like we did before. Again, we have the sine function, which is our y value. So if we go to the circle, where do we have a y value that is negative square root of 3 over 2? We know that because it's negative, it's going to have to be in the third and fourth quadrant. And if we look in the third quadrant, we'll notice over here at this point, which is 4 pi over 3, your y value is a negative square root of 3 over 2. And then over here in the fourth quadrant at 5 pi over 3, your y coordinate is a negative square root of 3 over 2. So here we would set this up instead of the previous examples, we would say x equals, but now it's going to be 2x because we're looking at this quantity here. So it's 2x is equal to 4 pi over 3. Now this one, we don't have an interval. Remember before we had the interval with some of the other examples of 0 to 2 pi. This one here, we're not looking at the interval. We want to look at all of the possible answers. So that means we're going to have to add on our multiple of pi or multiple of 2 pi. So with this example, we have 2x is equal to 4 pi over 3. And of course, if we want to get back to this location, just like we looked at it before, if we went all the way around and back, we would be adding on a multiple of 2 pi. So here again, we're going to be adding on this 2 pi n. Now, you want to make sure you add on the 2 pi n. Now, we need to get rid of the 2 over here because this is 2x is equal to 4 pi over 3 plus 2 pi n. So because this is multiplication, we're going to divide by 2. And if we divide by 2, we would be left with x equals. And if you have 4 pi over 3 divided by 2, that's the same thing as multiplying by 1/2. So therefore, we would end up with 4 pi over 6. Okay, so really we're thinking of multiplying here by 1/2, but we also multiply this piece by 1/2. So if we multiply this part by 1/2, the 2's are going to cancel, and you're left with pi times n. And of course here we can simplify this to x equals 4/6 reduces to 2 pi over 3 plus the multiple of pi n. And the important thing to realize here is that before we divide this 2 away, we need to make sure that we add in our multiple of 2 pi n because that has to be divided or multiplied. It needs to be multiplied by 1/2 or divided by 2. All right, so maybe pause the video and see if you can set up for the other angle, the 5 pi over 3. So this was looking at 4 pi over 3. So now we want to look at the 5 pi over 3. Well, once again, that means we would take our 2x and set that equal to 5 pi over 3. And we want to add on the multiple of 2 pi n. And to eliminate the 2, once again, we would multiply by 1/2. We multiply then by 1/2. The 2 and 1/2 cancels. We're left with x equals 5 pi over 6 plus pi n. So here we have our two answers for this equation. So again, what we notice that's different is instead of just taking the sign of 2x, we have the sign of 2x here. So we have to make sure that at the end we get rid of the 2 in this process. Okay, that's the only difference here. All right, I have one more example. We have 2 cosine, and this time it's x divided by 2 minus the square root of 3 is equal to 0. So maybe here you can actually pause the video, see if you can figure this one out. And it's going to be very similar to the first example, except for up here where it's 2 times x. Our only difference is that our angle here is x divided by 2. So once again, the first step is we need to isolate the cosine of x over 2, and that means we need to get rid of the square root. So we would have 2 cosine x over 2. So to get rid of the square root of 3, we're going to add that. So that would be a positive square root of 3 on the other side. And then we want to get rid of the 2, so we have to divide by 2. So we would have cosine x over 2 equals the square root of 3 over 2. So now at this point, again, I would suggest we know that we have to deal with this x squared of 2. So I'm going to go ahead and write this down before we forget. I know it's going to be x over, I'm sorry, not x squared of 2, but x divided by 2 is equal to, and this is where we go to the circle, where do we have an x coordinate? That is the square root of 3 over 2. Well, because we're looking for the x value, we know that it's going to be positive, so that's going to be in the first and in the fourth quadrant, because we're going to the right for a positive x, and that's going to occur at pi over 6 and at 11 pi over 6. So that means we would have x over 2 equals pi over 6, and once again we could always go all the way around and back, so we're adding on multiples of 2 pi, so we're going to add on 2 pi n. And once again here now we need to get x by itself, so to get rid of the 2 on the bottom, we're going to this time multiply everything by 2. So we would end up with x equals 2 pi 6 plus 4 pi n. So we could simplify this to x equals 2 6 reduces to pi over 3 plus 4 pi n. And that's our first part of the answer. And then again, we would need to take, for the 11 pi over 6, we would take x over 2, set that equal to 11 pi over 6. And once again, we could add on our multiple of 2 pi. And then to get rid of the 2, we're going to multiply everything by 2. So we're going to be left with x equals 22 pi over 6 plus 4 pi n. So if we simplify this, 2 into 22, we'd be left with 11 pi, and 2 into 6 is equal to 3, and then we add on the 4 pi n, and there we have the other part, our solution to this equation. So here we're looking at multiple angles, and again, this x over 2, realize that we have to set that whole part equal to the angle plus any multiple that we add on, and then you just simply solve the equation then for x.